1905 is considered a miracle year in physics. In 1 year, Albert Einstein published 4 papers that changed physics forever. They were about special relativity, the photoelectric effect, Brownian motion, and mass energy equivalence. These are all incredible discoveries that have had an impact on our lives and technologies we use every day. But it's not what most people think. In this video, I want to tell you the story of something that happened in 1905 that changed physics forever, but almost nobody knows about. This is the story of how scientists thought they had proven that Einstein was wrong. At the beginning of the 20th century, physicists were at each other's throats. Why? Because they disagreed on what the fundamental nature of light was. There were 2 main camps. One camp believed that light was made up of waves, similar to ripples that spread across the surface of water. The other camp believed that light was made up of particles called photons. This disagreement led to major controversy and debate, and it wasn't settled until 1905 when Albert Einstein proposed his theory of special relativity, which solved many of the problems associated with both of these theories. However, it would be another 5 years before Einstein's ideas were accepted by the majority of physicists. The reason for this slow acceptance is mainly because Einstein didn't do any experiments to back up his ideas. He just did thought experiments and made some mathematical derivations. However, in 1910, a young French physicist named Louis de Broglie stepped up to the plate and performed an experiment that once and for all proved that light is made up of photons, or as he preferred to call them, quanta. The experiment I'm talking about was an extremely clever demonstration known as the double-slit experiment. It's been around since the 1800s, but it took on new meaning after Einstein's work. The double-slit experiment works like this. You take a beam of light and pass it through 2 narrow slits. If the light is made up of waves, then it will interfere with itself and produce a pattern of bright and dark bands on the wall behind the slits, known as an interference pattern. The problem was, scientists couldn't explain why sometimes the pattern looked like this, and sometimes it looked like this. Now you might be thinking, well, obviously this looks like waves interfering with each other. But remember that in 1910, scientists believed that light could be made up of either particles or waves, but not both. So if they saw this interference pattern, they thought the light was acting like a wave. But if they saw this pattern, they thought that light must be made up of discrete packets of energy or photons. Young Louis de Broglie decided to tackle this problem head-on. He designed an experiment that was very similar to the double-slit experiment, except instead of shining light onto the 2 slits, he sent individual electrons, one at a time, through the slits. If each electron acted like a particle, then it should create a pattern that looked like this. However, when de Broglie looked at the screen, he saw this, an interference pattern just like when he had shown light through the slits. This experiment seemed to prove that light isn't made up of particles, but is instead a wave. But wait, there's more. A few months later, Albert Einstein explained the photoelectric effect and showed that light can also be made up of particles. This led to a lot of confusion, because how could light be both a wave and a particle? Eventually, this problem was resolved when Louis de Broglie came up with the idea that all matter has both wave-like and particle-like properties. That means electrons, protons, neutrons, atoms, molecules, and even electromagnetic radiation like light can all act as if they are made up of particles and as if they are waves. This is known as wave-particle duality. So what does this have to do with the experiment? Well, the key to understanding this is understanding that the electron is a particle. But that doesn't mean the electron doesn't also act as a wave. In fact, the wave-like behavior of the electron is actually more pronounced the less massive it is. And the wave-like behavior of the electron extends much further than just its location. The electron also has a wavelength associated with it, and its momentum is inversely proportional to its wavelength. This means that the more massive the electron is, The shorter its wavelength and the less massive the electron is, the longer its wavelength. This relationship between the wavelength of a particle and its momentum is known as de Broglie's relation. So now let's go back to the double-slit experiment. If each electron acts like a particle, then it should create a pattern that looks like this. However, we see an interference pattern, just like when de Broglie shone light through the slits. How is this possible? Well, it's because each electron acts as if it is a wave with a wavelength given by de Broglie's S relation. Since each electron is a particle with a certain momentum, it acts as a wave that interferes with itself. So even though the electrons are individual particles, they still produce an interference pattern because they also have wave-like properties. This is the same explanation that we use today to explain the double-slit experiment. In fact, without considering the wave properties of the electron, we cannot explain any of the observations made in the double-slit experiment. This experiment was the first of its kind to prove that all matter has both particle-like and wave-like properties. It earned de Broglie the Nobel Prize in Physics in 1929. Although the double-slit experiment is often used as an example of quantum mechanics, it can also be used to demonstrate classical mechanics. For example, if you increase the momentum of the electron so that its wavelength is short enough to be comparable to, or smaller than the width of the slits, then you no longer observe an interference pattern. In this case, the electron behaves more like a particle than a wave, and the interference pattern disappears. This is exactly what classical mechanics would predict. So depending on the circumstances, the double-slit experiment can demonstrate both classical and quantum mechanics. After Louis de Broglie's experiment was published, most physicists agreed that light was made up of photons. However, there was still a small group of physicists who refused to believe that light was made up of particles. The leader of this group was a French physicist named Louis de Broglie. Now you're probably thinking, wait, didn't Louis de Broglie discover that light is made up of particles? Yes, he did. But his name is different from Louis de Broglie, the French physicist who led the group of physicists who refused to believe that light was made up of particles. This guy is a completely different person. Anyway, Louis de Broglie didn't accept the idea that light was made up of photons because he couldn't understand how photons could travel faster than the speed of light. At the time, scientists thought that the speed of light was constant and that nothing could travel faster than the speed of light. This is known as the principle of relativity. Now we know that this isn't true, because according to Einstein's theory of special relativity, time itself can change, and it changes depending on your frame of reference. In other words, what appears to be faster than the speed of light could simply be an illusion caused by the changing of time. However, in 1910, scientists didn't know this yet. They thought that the speed of light was constant, and that nothing could travel faster than the speed of light. Louis de Broglie argued that if light was made up of photons, then the photons would need to travel faster than the speed of light to account for some of the observations made in the double-slit experiment. For example, if the photons traveled at the speed of light, then they wouldn't be able to interfere with each other. This is because the interference pattern only occurs when the waves overlap. If the waves don't overlap, then there is no interference. Now it is important to note that this argument is incorrect, because the speed of light is constant, and photons always travel at the speed of light. However, at the time, Louis de Broglie didn't know this, and he argued that if the photons traveled at the speed of light, then they wouldn't be able to interfere with each other, and the double-slit experiment wouldn't work. He therefore concluded that the double-slit experiment couldn't possibly be demonstrating wave-particle duality. Instead, he thought it was demonstrating some sort of hidden variable. However, in 1913, an American physicist named William Duane performed an experiment that once and for all proved that light is made up of photons that travel at the speed of light. This experiment was the first of its kind to show that photons travel at the speed of light. In 1914, Louis de Broglie admitted defeat and accepted that light is made up of photons. However, he continued to argue that this doesn't necessarily mean that all matter is made up of photons. This is where things get really interesting. Because in 1924, Louis de Broglie proposed the idea that all matter has both wave-like and particle-like properties. Now, as I mentioned earlier, this is the same idea that Albert Einstein used to explain the photoelectric effect and the double-slit experiment. However, Louis de Broglie didn't know Einstein's work because it hadn't been published yet, so he came up with the idea independently. Louis de Broglie published his idea in a paper in 1924, but it wasn't until 1927 that he received the Nobel Prize for it. So even though Louis de Broglie was wrong about some things, he was right about other things. In fact, his ideas were so revolutionary that they changed the course of physics forever. However, as I said in the intro, this isn't what most people think. Most people think that Einstein was the one who discovered that all matter has both wave-like and particle-like properties. And while Einstein did use this idea to explain the photoelectric effect and the double-slit experiment, it was Louis de Broglie who first proposed the idea. If you enjoyed this video, please leave a like and watch one of my other videos. Thanks for watching. See you next time.